Hello students, in this lesson we're going to learn about highest common factor or greatest common factor. But before we proceed, the question is, what is then a factor? A factor is a number which another number can divide by without any remainder. We said a factor is a number which another number can divide by without any remainder. For example, now when we have 4 divided by 2, of course we know that 4 divided by 2 is 2. So since 4 can divide by 2 and give you 2 without any remainder, so now we can then say therefore 2 is a factor of 4. Another example is that when you have 12 divided by 3, of course, 12 divided by 3 is equals to 4, right? If you have 12 oranges, you divide it to 3 people, you're going to get 4 oranges each, right? So since 12 divided by 3 will give you a whole number without remainder 4, then you can say that the number here, this 3 here, is a factor of 12. So right? So any number that can divide by another number without any remainder is a factor. So let's see some examples, right? Let's find the factors of some numbers for more understanding. So we have some sets of numbers here. The question says find the factors of the following. So the first number is 12. So the best way to find the factor of 12 now, in this case, is for us to start testing numbers from 1 to 12, and any number that 12 can divide by it without any remainder, we can therefore say that that number is a factor of 12. So let's see. The first factor of every number is 1, because any number divided by 1 will still give you that number. For example, if you have 5 divided by 1, it will always give you 5. So therefore 1 is a general factor of all numbers. We say 1 is therefore a general factor. So the first factor of 12 is 1, right? So the next one is 2. 12 divided 2 is equals to 6, right? So then 2 is also a factor of 12. Next one is 3. 12 divided 3 is 4. So since it will give you a number without remainder, we said then 3 is a factor of 12. Next is 4. 4 divided 12 is 3. So then that means 4 is a factor of 12. The next one is 5. 5 divided by 3, of course you're going to get remainder. You're going to have 12 divided by 5, right? Next one, 12 divided by 5, it will give us 2 remainder 2. So therefore 5 is not a factor of 12. Why? Because 12 cannot divide 5 without remainder. There will always be a remainder. So we'll skip 5, check 6. 12 divided 6, of course, is 2. So therefore 6 is a factor of 12. What of 7? 7 is not a factor of 12. Why? Because 12 divided 7 is 1 remainder 5, right? So 7 is not a factor of 12. What of 8? 8 is not a factor of 12 because 8 divided, you're going to have 1 remainder 4. So after 6, the next factor of 12 is 12. Let me confuse because 12 divided 12. I have 12 oranges divided by 12 people. Each of them will have 1. Each of them will have 1 orange. Is that not? So that means 12 is also a factor of 12. So the next number is 18. Of course, we said 1 is a general factor. So 1 will go. 18 divided 2 is 9. So 2 is a factor of 18. Next is 3. 3 divided 18 is 6. So that means 3 is a factor of 18. Next one is 4. 4 divided 18. Of course, there is a remainder. Is that not? Just remainder. So we're going to have 4 remainder 2. So that means 4 is not a factor of 18. The next factor of 18 is 6. Why? 18 divided by 6 is 3. So the next is 9. Why? Because 18 divided 9 is 2. And lastly, we have 18. 18 divided 18 is 1. The next number is 36. Of course, 1 is a general factor. Then 2, because 36 divided by 2 is 18. Then 3 can go because 36 divided by 3 is 12. Then we have 4, we have 6, 9, 12, 18, and 36. These are all the factors of 36. That means all these numbers 36 can divide by them without any remainder. Then the last one is 24. Of course, 1 is a general factor, right? Because 24 divided by 1 is same as 24. Then you have 24 divided 2 is 12, right? Then 24 divided 3 is 8. So we have 3. 4 is also a factor. Then we have 6 is also a factor because 24 divided by 6 is 4, right? Then we have 8, we have 12, and we have 24. So that's the factor. These are the factors of these numbers. I would say factor is a number which can divide by another number without any remainder. So by now, I think I believe you are comfortable with understand what a factor is, right? So let's move ahead. Alright, the next thing we need to understand is a common factor. What is then a common factor? What is then a common factor? A common factor is a number that can divide two or more numbers without remainder. So we said a common factor is a number that can divide two or more numbers without remainder. So for example, e.g., 3 is a factor of both 12 and 6. Is a factor of 12 and 6. Why? Because 12 divided by 3 is 4 and 6 divided by 3 is 2. So this 3 is a factor of both 12 and 6. So therefore we will say that what 3 is a common factor, right? It's a common factor of 12 and 6. Is that not? Another example here, we can say that 3 is a common factor of 12 and 9, right? 12 and 9, right? Why? Because 12 divided by 3 is 4 and 9 divided 3 is 3. So 3 is a common factor of 12 and 9. So we're going to see some example so that we'll understand it better, right? Alright, we have a question here. The question says, find the common factors of the following pair of numbers. And the first pair of numbers we have is 16 and 24. So let's solve it. Solution. So let's carry the first set of numbers. So that's A, right? 16. So what are then the factors of 16? That's the first thing we need to find. So the factors of 16 are, we have 1, right? We have 2, we have 4, we have 8, and we have 16. Why? 16 divided by 1 is 16. 16 divided by 2 is 8. 16 divided by 4 is 4. 16 divided 8 is 2, and 16 divided 16 is 1. So these are the factors of 16. Then the next one is the factors of 24. So we write 24. And the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So these are the factors of 24. So the next thing is to check. The next thing is to check what are those numbers that are in common between the factors, right? Since we said a common factor is that number that can divide two or more numbers without any remainder. So if we can check, we have 1 in common, right? So we'll go down and write 1, remember we said common factor, right? 1 in common. We have 2 again in common. So therefore we write 2. Then we have 4 in common. Can you see it? So we have 4. But again, we have 8 in common, right? 8 and 8. So remember, those numbers must be common before you write them. So these are the common factors of 16 and 24. Another thing we should put in mind here is that we are talking of highest common factor or greatest common factor. Then the question may come, what is then this highest common factor or greatest common factor? Highest common factor is the greatest or the highest number that can divide two or more numbers without any remainder. So in this case now, the highest common factor here is this 8. 8 is the highest common factor because among the common factors, 8 is the biggest, right? Or is the greatest. So we can therefore say the H.C.F, right, is equals to what? 8. Because highest common factor is the what? Greatest or the highest number that can divide two or more numbers without any remainder. And if you check, the highest common factor here is 8 because 8 is the highest or the greatest number that can divide both 16 and 24 at the same time, right? Let's go to question 2. All right, the second set of numbers is 15 and 35. So let's write down the factors of 15. We have 1 can go, right? Is that not? 1 can go into 15 because 1 is a general factor. Then the second one is 3. We have 5 and we have 15. So these are the factors of 15. Then what about 35? So what about 35? We have 1, we have 5, we have 7 and 35. So now, what are the common factors? So let's check for the common factors. We can see we have 1 and 1, right? So we said the common factor is we have 1, but again we have 5 here and 5 here. So we have 5, right? Is there any other thing? No, there's not anything in common. So these are the common factors, 1 and 5. Then what is then the highest common factor? So of course, among the common factors, the highest common factor now is 5. Can you see? Very easy. Very, very simple, right? Let's check the next one. So the next set of number is 20 and 32. So let's see the factors of 20, right? So 20, what are factors of 20? Of course, we have 1, we have 2, we have 4, we have 5, we have 10, and we have 20, right? Then for 32, 1 general factor, right? Then we have 2 because 32 divided by 2 is 16. And we have 4 because 32 divided by 4 is 8. Then we have 8. Then we have 16 and we have 32. So what is then the common factor? Or what are the common factors here? We have 1, 1. 1 is common. We have 2. 2 is common. We have 4. 4 is common. What again? Do we have anything in common? Of course, no. So therefore, these are the common factors. Then what is then the highest common factor there? The highest common factor here will be what? Will be 4, right? So 4 is the highest among the common factor. Very, very simple. Alright, the third set of numbers is 30 and 42. So 30, what are the factors of 30? We have 1, right? We have 2, we have 3. Why? Because 30 divided by 3 is 10, right? Then we have 5. 30 divided by 5 is what? Is 6. Is that not? Then we have 6. We have 10. We have 15. And we have 30. So 30 divided by 30 is 1. 30 divided by 15 is going to be what? 2. 30 divided by 10 is 3. 30 divided by 6 is 5. So all these ones are the factors of 30. So let's write down the factors of 42, right? So what are the factors of 42? The factors of 42 are, we have 1, we have 2, we have 3, we have 6, 7, 14, 21, and 42. So these are the factors of 42. So let's find the common factor. The common factor is what? We have 1, right? We also have 2. We have 3. They are common. But again, we have 6, right? Is there any other thing? Let's check it. 10, no. So there's no any other thing. So these are the common factors of 30 and 42. Then what is then the highest common factor? Is what? The highest common factor is 6, right? 6 is the highest common factor. So this is how to find the highest common factor and the common factor of pair of numbers. But there's a better way of doing this, in which I'm going to show you in a bit. So let's see. Alright, the question now is, what if then you are given larger or bigger numbers to find the common factors? For example, you are given 200 and 500 to write down the highest common factor or the common factors. Of course, you're going to start dividing a lot of numbers before getting to the 200, right? And you also have to divide a lot of numbers in order to get all the factors of 500. That's difficult. It might not be difficult, but that's a waste of time. Then how can we get it? The simplest way to solve the highest common factor of a pair of numbers is using prime factors. Prime factors. From the word prime factors, we can hear prime. What is then a prime number? A prime number is a number that is only divisible by 1 and itself, right? So prime number or prime numbers are numbers that are divisible by 1 and themselves. Only 1 and themselves. So for example, if you have 2, is there a number that can divide 2 apart from 1 and 2? No. So 2 is a prime number. The next one is 3. Is there a number that can divide 3 without any remainder? If you say you're going to use 1, of course 1 can divide. But what of 2? 3 divided by 2 is 1 remainder 1, right? So 3 is a prime number. And what of 4? 4, of course, 2 can divide 4, right? 4 divided 2 is 2, so 4 is not a prime number. Then we have 5, right? 5 divided 1 is 5. 5 divided 2 is 2 and a half. Is that not? 5 divided 3 is 1 remainder 2. Is that not? So that means 5 is a prime number. Another prime number here, we have 7, we have 11, we have 13, and so on and so forth. These are prime numbers and we're going to use them. So we've seen a prime number. We say a prime number is a number that is only divisible by 1 and itself, right? Then what about prime factors? Prime factors are the factors, as we have seen earlier, that factor is a number that is divisible by another factor without any remainder. Is that so? A prime factor now is a factor that is only divisible by 1 and itself. So a prime factor is a number that is only divisible by 1 and itself. For example, what are the common for example, what are the factors of 10? So if you check, the factors of 10 are 1, 2, 5 and 10, right? So one thing to note here is that 1 is not a prime number. 1 is just a universal number. So we said 1. So we say 1 is not a prime number. 1 is not a prime number, right? So since 1 is not a prime number, so what are the numbers that are divisible by only 1 and themselves among the factors of 10? We have 2 and we have 5. So these are the prime factors of 10, 2 and 5, because among the factors of 10, those numbers that are only divisible by 1 and themselves are 2 and 5. So these are the what prime factors. So we're going to use the prime factors to solve the highest common factors or the greatest common factors of pair of numbers. So let's try it and see. So in order to find the prime factors of a given number, the simplest way to do it is this way. So let's use 12 as an example. So you are going to write 12, draw a line. Remember, we said that the prime factors are 2, 3, 5, 7, 11, and 13, and so on. So this is what you're going to do. You're going to first check 2. If this number is not divisible by 2, then you move to the next number. If the number is not divisible by 3, you move to the next number, 5. If it's not divisible by 5, you move to 7. If it's not divisible by 7, you move to 11, and so on and so forth. So that's what you're going to do. On no occasion you will jump without checking 2 to 5, or you jump any prime factor. You have to follow them one after the other, except the number is not divisible by that prime factor, then you move to the next one. So let's see, the number we have here is 12. Is 12 divisible by 2? Of course, yes. 12 divided by 2 is 6, so we write 2 here. So 12 divided by 2 is 6. Is that not? Then check 6. Can 6 divide 2 without any remainder? Yes. 3. So that means 2 can go. So 6 divided 2 is 3. So 3. Can 2 divide 3? Of course no, because 3 is a prime number. So since 2 cannot go, you're through with this 2. You move to 3. So 3. Can 3 divide 3? Yes, because 3 divided by 3 is 1. So we write 3 here. 3 divided by 3 is 1. So therefore, we have 12 is equals to 2 times 2 times 3. So what are the prime factors of? So the prime factors of 12 are 2 and 3. These are the prime factors of 12. Very easy, right? Let's try one and see. What are the prime factors of 27? So as usual, we have the line here. Let's write down our prime factors here: 2, 3, 5, 7, 11, 13, and so on, right? So the first number, can 2 divide 27? Of course no. So we'll leave it. We'll move to the next number. Can 27 divided 3, of course, yes. 27 divided by 3 is 9. So we said 3 here is what? 9. So 9. Can 9 divide 2? Of course, no. You move to the next number. Can 9 divide 3? Yes. Because 9 divided by 3 is 3. So 3. 9 divided 3 is 3. What can divide 3? Is only 3 that can divide 3, because 3 is a prime number. So say 3 here is 1. So therefore 27 is 3 times 3 times 3. So the prime factor of 27 is 3. Is that not? So that's how to find the prime factors of a given number. So let's use these prime factors now to find the highest or the greatest common factors of pair of numbers. So let's give it a try. Alright, we have a set of questions here. The question says, using prime factors, find the highest or the greatest high common factors of the following pair of numbers, right? We have A, 20 and 32, B, 36 and 54, C, we have 20, 28 and 32, D, we have 108 and 132. Then E, we have 126 and 162. So the first one is 20 and 32. So in this case now, the first thing to do is to find the prime factors of individual numbers. So, and we've seen how to find the prime factors of numbers. So the first one here is 20. Let's write down our prime factors here. We have 2, 3, 5, 7, 11, and so on, right? So can 20 divide 2? Of course, yes. So 20 divide 2 is 10. So 2 can go. So say 2 here is 10. Can 10 divide 2? Yes. 10 divide 2 is 5. So that means 2 can still go. And 10 divide 2, 10 divided by 2 is 5. So give us 5. So what can divide 5? Can 2 divide 5? No. Can 3 divide 5? No. What of 5 divide 5? Yes. So 5 divided 5 is 1. We can say that 20 now is equals to 2 times 2 times 5. Right? Then what of 32? Let's go 32. Okay. Let's move to 32 now. 32. The first number we say 32 divide 2. Can 2 go into 32? Yes. So 32 divide 2 is 16. Right? Can 16 divide by 2 without remainder? Yes. How many times? 8 times. So we still say 2 can go. How many times? 8 times. Is that not? So can 2 go into this 8? Yes. How many times? 4 times. So we still say 2. 2 here, it will go 2 times. Can 2 divide 2? Yes. How many times? 1 time. So we can now say 32 is equals to, remember, is this one. You're going to use this side. These numbers. It's not magic. It's from there. So we have 5 over the 2. 2, 3. So 1, 2, 3, 4. So we have 4 of them. So what is then in common between these 20 and 32? We have 2 in common. Can you see? We have another 2 in common. So the H.C.F now is 2. We have group of 2's, 2 of them, which is what? 4. Right? So this is the H.C.F using the prime number method. But there's another short way of doing it using these prime numbers, is to bring the 20 and 32 together. But in this case now, you are going to look for a prime number that can divide both 20 and 32 at the same time. Remember that if the number can divide 20 and cannot divide 32, you are not allowed to use it. So it must divide both of them. And let's check, can 2 divide both of them? Of course, yes. 2 can divide, because 20 divided 2 is 10 and 32 divided 2 is 16, right? Is there a number that can divide both 10 and 16? Can 2 go? Yes. So 2. 10 divided 2 is 5 and 16 divided 2 is 8. So is there any number that can divide 5 and 8 at the same time without any remainder? Of course no. Because if you're going to use 5 here, 5 cannot divide by 8. You're going to use 2 here, 2 cannot divide by 5. So this is now your highest common factor or greatest common factor. We said H.C.F now is 2 times 2, which is 4. So you can see that this method is shorter, right? Still give us the same thing. Let's see the next question. So this is the second set of numbers, 36 and 54. So you can choose any of the method. You can use this. We said 36. What can go? Let's see. Our prime numbers now are 2, 3, 5, 7, 11, and so on, right? So the first thing, 2. Can 36 divide 2? Yes. 36 divided by 2 is 18. So we say 18. Can 18 divide 2? Yes. How many times? 9 times, right? Can 9 divide 2? No. So you have to leave it. Go to the next one. Can 9 divide 3? Yes. It can divide 3 times. So we're going to use 3 here. 9 divide 3 is 3. And what can go? Can 2 go into 3? No. What of 3? Can 3? Yes. So 3 divided 3 is 1. Right? So what of 54? Can 2 go into 54? Of course, says any number that ends up with 2, 4, 6, 8, and 0, 2 can go. Remember the divisibility rule? The divisibility rule says that any number that ends with 2, 4, 6, 8, and 0, 2 will always go. So that means 2 can go into 54, right? So if you have 54 and you don't have calculator to divide it, simple way to say it, you can say 5 divide 2. It will go how many times? So let's count it. 1, 2, 3, 4, 5. Divide 2. 1, 2. It will go 2 remainder. Then write the 1 here. You're now having 14. 14 divide 2 is 7. So 7. So it will give you what? 27. So 2 here is 27. Right? So can 2 go into 27? No, because the number did not end with 2, 4, 6, 8, and 0. So 2 cannot go. So can 23 go into 27? Of course, yes. And in the divisibility rule says that any number that after the addition of the individual digits is divisible by 3, then that means the number is divisible by 3. That is, if you have 27, you want to check whether it's divisible by 3, you're going to say what? 2 plus 7 is equal to what? 9. And 9 divided by 3 is 3. That means 27 is divisible by 3. So we say 3 here. 27 divided by 3 is 9. Can 9 divide 3? 2? No. What of 3? Yes. So 3 here is 3 and 3 here is 1, right? So 36 is this one here. 2 times 2 times 3 times 3, right? Then we have 54. This one's here will give us what? 2 times 3 times 3 times 3. So what they have in common? They have 2 in common. Is that what of again? They have 3 in common. They have these 3 in common. Is that not? So the H.C.F now will be 2, a group of 2, one group of 2. That means a group of 3. That means a group of 3, which will give us what? 2 times 3 is 6. 6 times 3 is 18. So the H.C.F is equals to 18. That's it. So using the other method now, we say 36 and 54, right? So we're going to use, we do for a number that can divide both of them at the same time. So 2 can go into this because it ends with 6 and this ends with 4. So 2 here. 36 divided 2 is 18, and 54 divided 2 of course is 27, right? So is there a number that can divide both 18 and 27 at the same time? 2 can divide 18 but 2 cannot divide 27, so you are not allowed to use it. Can 3 divide 18? Yes. How many times? 6. Can 3 divide 27? Yes. How many times? 9. So we are allowed to use 3 here. 18 divide 3 is 6, and 27 divide 3 is 9. Can 3 go? Yes, 3 can still go here and here. So we are allowed to use 3. 6 divide 3 is 2, and 9 divide 3 is what? 3. So is there a number that can divide 2 and 3 at the same time? No. So you stop here. So these are your H.C.F, right? So let's multiply them. The H.C.F is 2 times 3 times 3, which is what? 18. Very simple. Alright, this is a third set of numbers, and in this one here I'm going to use the second method so that we'll also be familiar with it. So we have 2, 20, 28, and 32. So what is that number that can go into all of them? All of them. 2 can go into all of them. So 20 divided by 2 is 10. 28 divided by 2 is 14. And 32 divided by 2 is 16. What can go into 10, 14, and 16? Of course, 2 can go. 5. Yeah? This one here is 14 divided by 2 is 7, and 16 divided by 2 is 8. Is that a number that can go into 5, 7, and 8? Of course, no. Because 5, there's nothing can go. 7, no. 8, 2 can go, but 2 cannot go into 5 and 7. So we can now say our H.C.F is equal to 2 times 2, which is what? 4. Right? So this is the fourth set of numbers, 108 and 132. So let's use the second method. So 108, 132. Of course, any number that we say that ends with 2, 4, 6, 8, and 0, 2 can go. So that means 2 can go into 2 of them because this is 8 and this is 2. So 2 can go. So we have 108 divided by 2. You don't have calculator, how are you going to divide it? You know that 10 divided 2 is 5, and 8 divided 2 is 4. So we have 54 here. 54, right? Then what about 132 divide 2? 13 divided 2 is going to be 6, remainder 1, right? And 12 divided 2 is 6. Can you see? We're going to have 66. So is there a number that can go into 54 and 66 at the same time? Of course, yes. Because it ends with 4 and this one ends with 6. So 2 can go. So 54 divided by 2. So let's see. We said 54 divided 2. So 5 divided by 2, it will go 2 remainder 1. Write the 1 here. 14 divided by 2 is 7. So we have 27 here. What can go? 66 divided by 2. 6 divided by 2 is 3. And 6 divided by 2 is 3. So we 3. Right? Can 2 go into 27 and 33? No. What is that number that can go into 27 and 33 at the same time? I think 3 can go, right? So 3 here, 27 divided by 3 is 9, and 33 divided by 3, we have 33 divided by 3. 3 divided by 3 is 1, and 3 divided by 3 is 1. So we have 11. So is there a number that can go into 9 and 11 at the same time? No. So that is our HCF. So I will say our HCF is equal to 2, this one's here, right? So 2 times 2 times 3, which is 2 times 2 is 4, 4 times 3 is 12. So this is the H.C.F, right? The last number we have here is 126 and 162. So let's use the square method. So what can go? Of course, 2 can go, right? So 2, because it ends with 6 and 2. 126 divided 2. 12 here is 6, and 6 divided by 2 is 3. We have 63, right? Then we have 162 divided by 2. 16 divided by 2 is 8, and 2 divided by 2 is 1. So we have 81. So is there a number that can go into 63 and 81 at the same time? 2 cannot go into 63 because it did not end with 2, 4, 6, 8, and 0. So 2 cannot go, but 3 can go. So 3 here, we say 3 can go because 6 plus 3 will give us 9. And 9 divided by 3 is 3. So 63 divided 3 is 63 divided 3. So 6 into 3 is how many times? 2. And 3 divided by 3 is 1. So it will go 21 times. And 81 divided 3 is what? Is 27. What can go into both 21 and 27 is 3. 21 divided by 3 is 7. And 27 divided 3 is 9. Since there is no n number that can divide both of them at the same time, we can now say our H.C.F is equals to 2 times 3, 2 times 3 times 3, 2 times 3 times 3. 2 times 3 is 6. 6 times 3 is 18. So it's equals to 18. Right, with this, we've come to the end of the lesson. Try your possible best to get some questions and solve them. Practice make perfect as usual. So until then, see you in the next video. Thanks for watching.